Hello all, let us look into examples of SDD which are of type inherited attribute. Few more examples. This is second example. We had done a previous example with just a star operator. Only these four productions were there. So it is a simple test calculator with inherited attributes with the operator star. If it is more than one operator, like you can also add plus, minus, division for that, and you can extend the string like this. And since it is similar to the previous one, you can try yourself. Moving on to third example. Try dependency graph, order of evaluation for the following, and SDD and annotated parse tree. So if that is the case, how do we do? First we will do only these two as we discussed earlier. Later, after giving the introduction to dependency graph and evaluation of order of evaluations, we will discuss that later. So this is our productions, which also includes along with ID a number also. Okay, so which is same as the previous example, but additionally you have parenthesis as well as number production. So which might be of this kind, string a minus 4 plus c. This problem has also appeared many times in the exam. So for that we just start doing the annotation of the parse tree. First we start for the derivation. E produce t e, where t produce id and this e produce minus t e, and this t produce num and e produce plus t e. This t produce id and e produce epsilon. As per the given productions, we have written all this in order to obtain a, number 4, and c. A minus c plus, so a minus a minus 4 plus c. So your string is a minus 4 plus c. So this is a minus 4 plus c. A minus 4 plus c. Okay, a minus 4. After this, let us annotate the tree. So annotations makes use of now the procedure dot lexval is a, because I have to obtain a. So and that value is being considered as synthesized. Next, this operator requires two values for the computation. So that's why it takes a value from the sibling. Therefore, this inherited value becomes a now, and this a comes down here for the computation. So it becomes a minus 4. Okay, for computation of this 4, you have to take the value from its leaf node. So num dot lex value is obtained from the symbol table as 4, and that has been moved here. Now you got a minus 4 as an inherited value of e. Now this value is coming down for the computation of this plus. Okay, so this is coming down e. This e is having an inherited value called such as this value plus this value. So what is the value of t? T is c. It's coming up. Okay, so a minus 4 plus c is your computed value. And because of this epsilon production, this inherited value is converted into synthesized value. Change it to synthesized value and assign that value, a minus 4 plus c. And again, once this synthesized value is obtained, and always synthesized value move up. So it has to move here, it has to move here, it has to move here. Finally, you obtain a minus 4 plus c. So that is what annotated parse tree. And you can also write SDD for this writing the production along with the semantic rules is called as SDD, syntax directed definition, that you are writing. So this is what our first production to be computed, because we know that it is a lexical value. num.lex value has been assigned to this. Similarly, t produce id is id.lex value assigned to t, and similarly here just e value is assigned to t. Assign it. Because of this production, your inherited value is converted into synthesized value, and this is, you can also notice here I am using some subscript as 2, 1 and dash and all. It is just to know the difference between two nodes. You are performing between two nodes as though it is same node, so same symbol in the production, but in the tree, parts tree, the nodes are different. Okay, that's why we are using this suffixes. Next, because of this production, if you go back to tree, here what you should do, take this production and moving here. So this is what your subtree. Here what is that action you are performing? You are computing the value, that is inherited value, and this synthesized value is moving up. So this value is moving up. Okay, so this value, sorry, here it is moving up. Therefore only two actions: compute the value with subtraction, and synthesized value is moving up. Same way we will consider this also. So plus, where the pluses, so this one, this is our subtree. So what is that happening here? The computation of inherited value and the synthesized value is moving up. So only these two are there. So write them as a semantic rule. So you obtain these two rules. Moving to next, the last production. So here there are only two actions that you are performing. So the actions are, this is one action taking inherited value, and this synthesized value is moving up. So write that t val is borrowed from the sibling, so it is inherited value, and synthesis value is moved to root value. Therefore it is done. So two actions, rest all is one actions for this, and only in these three productions you have two actions. This completes SDD for this particular production. Okay, but actually they have asked for dependency graph also and order of evaluation. We'll understand that in next video. First giving the definition to these two. Thank you.